Today's focus will be on density. And density is a ratio of a mass of an object compared to its volume. Just like with speed, which is a relationship or a ratio between some distance versus a given amount of time, neither unit of mass or volume defines somebody's density. Instead, it has to be the relationship between the two. So you can't just judge by somebody's mass being, or something's mass being 12 grams in order to determine its density. You need to understand, is it 12 grams for 1 milliliter, or is it 12 grams for 400 milliliters? So the formula for density is mass divided by volume. And once again, we're going to bring back this triangle, and the triangle tells you to take your mass divided by volume in order to determine density. Remember, with these triangles, what you do is you cover up whatever you are trying to solve for and follow along with that multiplication or division that it tells you to do. So if I'm trying to solve for density, you cover that up and it tells you mass divided by volume. If I'm trying to solve for mass, you cover up mass and it tells me to take density times volume. Some various units of density are any unit of mass versus over any unit of volume. So I could use any unit of mass, which means I could use grams, kilograms, pounds, anything. And then I could use any volume unit, milliliters, cubic centimeters, gallons. So any of these where it's a relationship of some sort of mass unit divided by some sort of volume unit, you're good on density. Typically in this class, we're going to be grams per cubic centimeter or grams per milliliter. And that means we are going to take milliliters or cubic centimeters. And I just want you to understand that these two things are the same as each other. And there are labs that can prove this, but if I say 12 milliliters, it is the same thing as saying 12 cubic centimeters. So let's try to do one of these calculations. So for every 5 grams of mass of a golf ball, there is 20 milliliters of volume. What is the density of the ball? So I'm going to fill in my chart, and I've got 5 grams is my mass, and my volume is 20 milliliters. I am asking to solve for my density. So I'm going to cover up my density on this formula. I'm going to take its mass unit, which is 5 grams, and divide it by its volume, which is 20 milliliters. And when I plug it into my calculator, I'm going to get 0.25. Remember, we are going to want decimals in this class and not fractions. And the units are grams over milliliters. So I'm going to do grams per milliliter, which is the unit of density, or a unit of density, where it's a ratio of a mass unit divided by a volume unit. Using the density you just calculated, if a golf ball has a mass of 10 grams, what is its volume? So in this case, I'm going to use the previous unit, or the previous slides density unit, which is, or density calculation, which is 0.25 grams per milliliter. And my volume unit for this one is 10 grams. And I am asked to solve for volume. So in this case, I'm going to cover up my volume, and I'm going to take mass divided by density. So my mass is 10 grams. My density is 0.25 grams per milliliter. And so when I divide it out, I get 40 milliliters. Now, how do I know what unit I'm going to utilize for my volume? Well, the top unit of your density is going to be your mass unit. The volume, or the bottom unit, is going to be your volume unit. So in this case, because I'm trying to solve for volume, it is going to be the same unit, which is milliliters. So sometimes the density of an object can be determined by seeing if it sinks or floats in a substance with a known density, such as water. And it's always going to be in relationship to whatever substance you're comparing it to. So if it floats, then it's going to be higher, or it's going to have a density that's lower than the substance it's in. And if it sinks, it's going to have a density that's higher. So in water, water's density is 1 gram per milliliter, or 1 gram per cubic centimeter. So if an object floats in water, the density is going to be less than 1 gram per milliliter. If it sinks in water, then the density is going to be greater than 1 gram per milliliter. So it's all in relationship to it. Draw a particle picture with an object that sinks and one that floats in an object or in the substance. So something that would float is going to be above it. Okay, I'm going to make it I can either make it a cube, or if I wanted to do a particle picture, I would just make it more uniform. So here's something that is floating. And something that would be sinking would be something that is on the bottom. So from these pictures, what I can tell is the substance on the right is going to be more dense than the substance it is put in, whereas the one on the left where it's floating, this substance is less dense than the substance it was placed in. So one way that you're going to be able to measure density is you would need to use the technique of water displacement. Now, water displacement doesn't really tell you its density, but what it can determine is something's volume. So when an object is submerged in water, it will displace or push out of the way some of that water. By measuring the change in water level, the volume of the object can be determined because the volume that the water displaced is equal to the volume of the object. This technique is extremely helpful if you need to figure out the volume of an irregularly shaped object. And you guys know all about water displacement because if you've ever taken a bath, here's my bath. Okay, it's not really a great tub, but if I have a water level and then I step into that bath, what's going to happen? That's my foot. What's going to happen is that original bath line is now going to rise. Why? Because some of the water was displaced by parts of my body. All right, so this is true. Let's try to do a calculation of volume with this dinosaur. If you look at the dinosaur, it's very irregularly shaped. So to actually calculate its volume, it would be impossible to do any formula that you would learn in math to do. So the first thing is that you need to figure out how much water is in it originally. And this is going to be 4.8 milliliters. Why? Because it's 4 and there's 5 tallies between the 4 and the 5, which means everything is 0.2. So this would be 0.8, so it would be 4.8. And when I put the dinosaur into it, it went all the way up to 5.6 milliliters. So what I'm going to do to figure out my volume of my dinosaur is I take its final volume, which was 5.6, I subtract how much water was in it, which is 4.8 milliliters, which was my initial one, and I get 0.8 milliliters. So the volume of that dinosaur was 0.8 milliliters. So similar to distance versus time graphs, where the slope is equivalent to the speed of an object, the slope of a mass versus volume graph is equal to the density. So it's really important when you do these that you understand that if I have a mass versus volume graph, I am able to calculate an object's density based off of calculating its slope. Mass needs to be written on the y-axis though, and volume has to be written on the x-axis in order for this to work. And that's the reason why is because when you take the slope of rise, which is changing of your y, over run, which is changing of your x, you need to be able to have your units correspond to that of density, which is mass over volume. So therefore, I need my y to be my mass unit and my volume unit to be my x unit. All right, so comparison, what you can tell is I could calculate the slope of this, of my mass versus volume graph, and the slope would be equal to my density. But in this case, the question is not asking that. It is just asking which liquid is more dense and how do you know? So I just look at my two lines. I've got a line with a steeper slope than one with a shallower slope. And the one with the steeper slope is going to have a bigger density, which means it is more dense. So in this case, this guy right here, liquid 1, would be my more dense. And the reason why you know this is because the slope is equal to your density and your liquid A, or liquid 1, has a steeper slope, which means it has a higher density.